Talk about some different types of problems, so I would suggest having the factor sheet out because I will kind of reference that. So we're going to do this sheet today. We'll take a break. We have a notes quiz we need to do, open notes quiz, and then we just have time for homework. So now on the test, you guys, I will not tell you what method to use. Guys, I really need you to stop talking, please, especially since I have a video going. So I'm not going to tell you guys which method to use. So on here where it says factor by reverse FOIL, that's only to remind you guys like all the different. But again, on the test, I won't tell you. It'll just be kind of a big factoring section. And it's pretty much the whole test because that's all we're doing in this. So factoring by a GCF, we're going to pull out what's common among the terms. So between the 8 and the 6, what number is common? Yep, 2. And then how many m's? 2 as well. So 2m to the second can be taken out. So we're going to factor that out of each of these. And again, I'm just doing practice problems from the test. So this is kind of just review with you guys for you guys to kind of go through some different types of problems. So 8 divided by 2 is 4. M to the third over m is just going to be m. 6 divided by 2 is a negative 3, and then the m's will just cancel. Now, because of what we learned last class, we talked about can you factor further? Now, if I look at 4m minus 3, this doesn't factor anymore. They're not perfect squares. 4 is, but m is not. 3 is not. It's only 2 terms, so we're done. That's all we do here. So that'd be it for factoring by a GCF. So factoring with reverse FOIL. This is the one that I did a lot of these questions when we did that Kahoot. So with a lot of these are, I think, are the fastest ones in my opinion if you're good at factors. We don't have to do the X thing for this. So reverse FOIL, the reason why I can do this method is because I know it's x squared, so I know it already starts with x and x. And I want to multiply to get a negative 28, but add to get a negative 12. And this is something that I'm hoping that when you leave here, like if any type of factoring sticks with you, this one does. Because I think it's the most logical. I know Mr. Hatfield was just talking to me about some of his Algebra 2 students who couldn't remember how to do this. And it was really frustrating to him because it's like, it's not that, he's like, I know they learned it at some point. So multiplying to get negative 28, adding to get negative 12. So again, this might be where your factor chart might come in handy. If you want one, like I said, we can print some more today. You don't have to make a whole list. It's just me trying to get you guys thinking about it. But I want it to be a negative 12, so the bigger number has to be negative. So this is where the negative 14 and 2 come in. And then we're done because this can't be factored any further. All right. The next thing we learned was grouping, but again, it will not tell you to use grouping. If it has 4 terms, you should try grouping. You should look for a GCF first, if at all possible, but this one doesn't have one anyway. So grouping is where we do 2 and 2. So I'm grouping these into 2 parts. And so out of the red part, I'm going to ask what can be factored out. What's the GCF of those 2? So 6x to the third minus 15x squared. Chase, what do you want to take out? 3x squared. And you want to take out as much as you can. If you leave extra stuff behind, this just won't work. So we take a 3x squared out because that 3 is common, but so is the x squared. So we're left with 2x and then a minus 5. Out of the 10 and negative 25, you can take out a 5. Bless you. And again, they should match. So 2x minus 5. So I have the same thing twice. So now I have to rewrite it. A lot of you guys on your scrimmage stopped here. this is not the end of this problem. We have to write it one more time. So now what we do is we take this and we say what's common among these two terms. And then the leftovers are 3x squared plus 5. Now, the question is that factorable there? It's two terms, but in order to be two terms, it has to be subtraction, and they both have to be perfect squares, and 3 and 5 aren't perfect squares. So we stop here. All right, questions? All right, we're gonna flip it over. I say let's just get this whole sheet done first, and then we'll take a break. Okay. Oh, that's not it. There it is. All right. So now these next two are X factor, but they're two different types. Well, I say they're X factor, but they're actually not both X factor. So the big thing with any problems like this, always look for a GCF first. So if you guys are working ahead of me, I just want to tell you to be careful. Number 5, you should always look for a GCF first, but this one has a GCF. And taking that out first will save you a ton of time and like extra issues and potential for mistakes. So you should always do that, but number 5, there actually is one. Now number 4, there's not one. 6, 1, and 12 don't have a common factor. So this one we do have to do the X factor for. And if you're still struggling on this, please come in for help. Today for AR would work really well. Monday AR would be a great time to come and get for help. So knowing that you have those times, you guys are always welcome to come see me. So what we do on the top is we put these two together. So 6 times a negative 12, so that's a negative 72 x squared. On the bottom I put 1x. Now 72 is a number with a lot of factors, but I know already, like again, doing a little bit of puzzle solving, and the more practice you do with this, the better you guys will get. I know the numbers need to be really close to each other because they need to end up being 1. Does that make sense? So like when I put them together, they end up being 1. And one's going to be a positive and one's going to be a negative. So kind of thinking ahead a little bit as I do these. Now again, if you don't notice it right away, you can make your list. This is going to be a pretty long list. So I think a lot goes into 72. That's 14, is that right? 24, thank you, sorry, good catch. So yeah, lots of things go into, I'm not gonna make this whole list, it's kind of crazy. What I realized is negative 8 and 9 multiply to give me 72, but when I add them, they give me a positive 1. So again, I knew they were really, like they were right next to each other because of this 1. Now it doesn't matter which one you put first. I'm going to put 9x first and then minus 8x. I use that to split this middle term up. And again, I'd be glad to walk you guys through this, or if you absolutely hate this method, I can show you another method. So now we're going to do grouping. Wohlers is having a meltdown across the hall, I think. So out of the first two, we can take out a 3x. I'm left with 2x plus 3. Out of the next two, I can take out a negative 4. And I rewrite it one more time. So in order to get this fully correct, I know it's a lot of steps, you do have to write it as those two things multiplied together. And understand there's not going to be like 8 of these questions on there, there's going to be a few. So like if you don't know how to do this one, you are not going to fail the test. I will tell you that 100%. But if you don't know how to do a bunch of these, you're going to fail the test. So like not being good at one type of these factoring, you're going to be okay. But obviously, if we can get you good at all of them, get you doing fine on all of these, we want to do that. Now, so example 5 is the one I said that it actually does have a GCF first. If you forgot to take it out, you probably had a lot more factors to work with. It was probably a longer problem. And at the end, you probably still need to factor it. But if you notice, you can take out a 2 first. It's going to save you a lot of time. Because now, this becomes the nice type of factoring that I think all of you guys are capable of being really good at. X and X, multiply to negative 14, add to negative 8. Does this one work? Oh, that's annoying. Sorry. Yeah. You and Brady noticed that. All right, so this one doesn't work. So we just stop here, or we'd say like the rest of it's not factorable. But that's also not the worst thing for us to have come up. So understand that some problems just aren't factorable. But again, I'm going to tell you guys right now, please know that if there's one question on the test that's not factorable, that's it. There is not going to be like 10 of them. So I've had students turn in a test and they like write not factorable for like 5 or 6 questions, and I'm like, oh, like, you know, like I can't give you points for that. So please make sure that if you think like you weren't able to factor any further, this is probably the only question like that on the test. So our next one says to factor completely. I guess I forgot to do the special case one on here, but we're going to do probably whiteboards here today. So we'll. What? All right, we're factoring completely. So what can I do first here? Yep. Yeah, 7 actually goes into both of these. If you're ever unsure, try it with your calculator. Divide 63 by 7. And you end up with 9. But it says to factor completely. Now, technically, I should say that all the time, and maybe I do on the test. I can't remember. But really, you should always keep trying. So this now is like the first column on our chart. So this is difference of squares. They're subtraction. They're both perfect squares, so it's x and x. Multiply to get 9, get them to cancel. It's 3 and 3.